Okay, so we've got sum up until infinity. So I know I'm going to use my sum into infinity formula and so on. So we're going to say S to infinity is equal to A over 1 minus R. Now we first need our A. Okay, so let's find our A. So we know that my term starts at term 1. So it's going to be 2, 1 minus 1, and that will be 2 to the power of 0, which will be 1. So my A is equal to 1. So S sum of to infinity is going to be 1 over 1 minus, and my R is 2. So this will be 1 over negative 1, which will be negative 1. Okay, I'm going to quickly do the sigma notation. So I know I jumped around a little bit, but sometimes the sigma notation, they give you a different starting term. Okay, so I'm going to get us an example quickly of where they give us a different starting term. So we've got the evaluate and expand. Okay, so if they say evaluate and expand the sigma notation, so let's have a look here. All right. Sorry about that. Okay, so let's determine how many terms there are in the series. So to determine the number of terms in the series, so it started at 5 and it ended at 12. So we take 12, so the top, minus the bottom, plus 1. So that was top minus bottom plus 1. Okay, so this will be 12 minus 5 is 7. 7 plus 1 is 8 terms. So from term 5 to term 12, there are 8 terms. Okay, so if we evaluate this the sequence, then we need to make sure that it starts at term 5 and it goes up until 8 terms. Okay, so my first term, if I go, let me just get my calculator. Sorry about that. Okay, so I know that it's going to be the 8th term, so let me expand it quickly. So remember, we're starting at our 5th term. So 3 times 3, 2, k is 5 minus 5. So this will be 3 times 2 to the power of 1. So this will be 6. So that's my first term. My second term, so if I do this with my second term, remember your second term is 6. So 3, 2, 6 minus 5. So that will be, sorry, 5 minus 5 is 0. Okay, so that is 3. This one is 6. Okay, then my third one, so remember it's going to be the 7th term because it goes term 5, term 6, term 7 because we started at 5. Okay, so this will be 3 times 4, which will be 12. So 3, my sequence or my series will be 3 plus 6 plus 12 up until my 8th term. Okay, yeah, so until term 12, but we've got 8 terms until then. Okay, so let's see. We are going to do our, we're going to evaluate the sigma notation. So I know that this is a geometric series. My R is going to be 2 because I'm multiplying by 2 every time. So remember, let's just work that out quickly. Sorry, this seems very all over the place, but our R is term 2 over term 1, which is 6 over 3, which is 2. Okay, so let's determine this. So Sn is equal to A times Rn minus 1, and I use this one because my R is greater than 1. Okay, and then my Sn is going to be up until my 8th term. So A is going to be 3, R is going to be 2, my N is 8 minus 1, and so this is the sum for 8 terms, 2 minus 1, so this will be 3, 2 to the power of 8 minus 1, and then if we work that out on our calculator, we get an answer of 765. So it went from term 5 all the way until term 12. We know there are 8 terms here. So I'm looking at what is my total calculation for 8 terms. All right, if I started at number 5. Yeah, term 5. Okay, so I hope this was helpful. I'm sorry about the break in between, but yeah, hope you have a good day.